We want to take a look at creating equations of parallel and perpendicular lines given certain information about another line. So just a reminder from some previous units or some previous classes is some information about some of the different forms of an equation of a line. So we have point slope form, y minus y1 equals m times x minus x1, where m is our slope and x1 comma y1 is a given point on the line. So those are numerical values in when we see an actual equation. They won't be left as variable values. Y equals mx plus b, m is our slope, b is the y coordinate of the y-intercept, so that's 0 comma b is how we traditionally write the y-intercept. And then I've added on here standard form. The a, b, and c alone don't tell us very much, but when we combine them together, we do find a very important piece of information, which is our slope, which we find by taking the opposite of a value divided by b. So we're going to use this information in order to write equations of lines that are parallel and perpendicular to the given line containing the given point. So what this means is, you're thinking on a coordinate grid. I'm giving you a line. I'm giving you the equation of that line, and I'm giving you a point on that line, and I'm saying, hey, all right, find me an equation of a line parallel to it and a line perpendicular to it. All right, so we're going to find both equations of both of those lines. Okay, so number one, the line given is in slope-intercept form. So we know a couple of things. We know a slope and we know an intercept. Okay, one of those is going to be more useful than the other to us. Okay, but we're also given a point, which is going to be very useful. So I have a form of an equation of the line whose literal name is point slope form. And I'm going to use that because I have a point and I have a slope. Okay. And excuse me, in this drawing, this point should be over here, not on the original line. Okay, so I want a line that has that same slope, right? Because we're thinking parallel first, same slope, but going through this 0.24, which is not on our original line. So we're going to start with point slope form. So point slope form is say y minus my y value of my point, 4, equals my slope, 2, times x minus my x value of my point. And you're done. That's it. If I graphed that line that I just wrote, it'll be parallel to the initial one. So what do we need to do different for perpendicular? Well, not much, because the only thing that'll be different about the perpendicular line is going to be its slope. It should be the opposite reciprocal. So the slope in the perpendicular line should be opposite, so it should be negative, and reciprocal 1 over 2. So let's make that change. The point stays the same, so it's still y minus 4. Now what needs to change in the equation is that my slope needs to be negative 1/2. And we're done. So we need to just identify the slope and determine what needs to happen depending on if it's parallel or perpendicular. All right, next one. So we have an original equation. It's in point slope form. The only piece of information I need out of this equation is the slope. The slope is negative 3, that number right there in front of the parentheses. And then I need the point that I want my new line to be going through, because I'm going to put this in point slope form, right? So y minus 6 equals, we're doing parallel, so same slope, negative 3, x, and be careful because we're subtracting a negative 1, so I'm going to write that as plus 1, right? So x minus negative 1 is really x plus 1. And you're done with the parallel. So let's do perpendicular. So what needs to change? Here, my slope needs to be an opposite reciprocal. So it should be positive, and it should be 1/3. Everything else stays the same. We're still going through the same point, so y minus 6 equals now a positive 1/3 for my slope, x plus 1. So again, same point, different slope. Okay, last one. This is standard form. So in order to get the information about our slope, we have to do a little bit of extra work. Right? Our slope is the opposite a value, negative 2, divided by the b value, which here is a positive 3. And then we have a point, and we're going to go about it the same way we did the other two. So y minus the y value, so y minus -3 is really y plus 3, equals, it's parallel, so it should have the same slope as my original line, -2/3, and then x minus the x value, which is 2. Now for perpendicular, I need the opposite reciprocal slope, so it should be positive, and it should be 3/2 instead of 2/3. Okay, so y plus 3, because the point's not changing, the only thing that's changing is the slope. So 3/2 instead of -2/3, and then x minus 2, because again, point staying the same. So now we have lines describing other lines that are parallel or perpendicular to our original lines.